Numbers 9 through 16, we see we have variables under the radical. It does not change anything we do. In fact, when we see variables, it should become a little bit easier. We're looking for the square root of this number, and we have 2 times 6, 2 times 3, so we're going to rewrite what's under the radical in prime factored form. So 12 can be factored as 2 times 2 times 3, and x is its own factor, and since this is a square root, we're looking for pairs of the same factor, and we see we have a pair of 2's, so we get to pull a 2 out, and we don't have a pair of 3's or a pair of x's, and so we're just going to go ahead and leave those under the radical, and that's it. You should go ahead and try number 10 on your own. Pause the video, try number 10 on your own. And here we go. We're going to rewrite 18 as 3 times 6. You can do it another way if you want. 2 times 3. So we have 2 times 3 times 3, and then we still have that x. So we're looking for the square root, and so we're looking for a pair of like factors, and so we get, we see we have a pair of 3's, so we get to pull a 3 out, and we're left with 2x under the radical, so congratulations if you got that. Number 11, we're looking for a cube root, and so we still do the same process here. 24 can be written as 2 times 12, then 2 times 6, and 2 times 3, and prime factored form of 24 is 2 times 2 times 2 times 3, and we still have that x in there. We're looking for a cube root, so we're looking for a group of 3 factors, and so we have a group of 3 2's, and so we get to pull a 2 out. What's left inside the cube root symbol is the 3 and the x, and so be careful when you write that 3 right there. You got to write it like right just above the little bend in the radical sign there. So make sure you don't write that as like 2 times 3 times the square root. So just be careful with that. I got a little bit sloppy there, so I'll try to be better in the future. Go ahead and try number 12 on your own. Pause the video. And 54, negative 54. I'm going to actually start showing you a different way to do these. You've seen the way I've done them before, but in this one, I'm going to look for a factor of negative 54 that's a perfect cube. And I know I can rewrite negative 54 as negative 27 because I know my cube roots times 2, and then I know that my r to the 4th can be written as r cubed times r. So this is more of the kind of the fast way of doing this, and I forgot to write the little cube root symbol. Don't forget that. But negative 27 is a perfect cube. R cubed is a perfect cube. So if we have a negative 27 under the cube root symbol, we get to pull a negative 3 out. R cubed, since it's a perfect cube, we get to pull an r out. Now, if that was a little bit much for you, I understand. So just go back to the old way of writing everything out. And if by chance that's something you did, you would have it, it would look like this. A negative, let's see, 54, I'll write it like this, 54, 2 times 27, and then we have 3 times 9, and then 3 times 3. So with that negative in there, we could write it as negative 1 times negative 1 times negative 1. So we have a negative 1 we can pull out. And then we have the 3 times 3 times 3. Then we have the 2. Then we have the r times the r times the r times the r. So if we did this the same way we did the other one, we can pull a negative 1 out, we can pull a 3 out, and we can pull an r out. Negative 1 times 3 times r. And what we're left with is that 2 and the r underneath the cube root. So that's just another way of going back to how you did this before. Now, we're going to get into multiplying these together, and once we multiply them together, we just use the same process that we've been using. So let's go ahead and realize that we have a square root and a square root. That means we can write it as one big square root, and 12 times 3 is 36. X times x squared is x cubed. Well, one way you could have done it is you could have left the 12 and the 3 in there and then factored the 12. But nevertheless, I know that the square root of 36 is 6 times 6. So I'm going to leave it like that, 6 times 6. And then I have x times x times x. And again, we have a square root, and so what we're looking for is pairs of the same factor. So anytime we have a pair of 6's, we get to pull a 6 out. We have a pair of x's, we get to pull an x out. And we don't have any more pairs. And so what's left under the radical is just the x. So we have 6x times the square root of x. I guess a third video for the next 3.